Good morning. Welcome, welcome. If you'd like to take a moment to use the chat button and drop where you're joining us from today, be greatly appreciated. You are at The Future is Now, empowering youth through STEM excellence and OST. Our first webinar series is titled Introduction to STEELS, leveraging the new STEM standards in OST. We'll go ahead and jump right in here and get started. I'll introduce myself. My name is Control Armour, the director of the Pennsylvania Statewide After School Youth Development Network, and I'm a proud director to welcome you all here this morning to our STEM webinar series. Just to give a shameless plug to the next 5 webinars that we had. If you hadn't registered, pay attention later on in the chat before we close out, and we'll drop the link in there for you to register for the remaining sessions that we have. But for today, I am very, very happy and excited to introduce you to our presenter, Dr. Colleen Epler-Ruths. Colleen Epler-Ruths, Colleen Epler-Ruths is the STEM educator consultant at the Central Susquehanna Intermediate Unit here in Pennsylvania. She has 20 plus years of experience in public science in the public science classroom, where she taught physics, computer science, and other science courses. Her PhD work focused on spatial skills, impact on students' science learning. Besides being a tech guru, she's an outdoor enthusiast, Penn State Extension Master Gardener, lead for the Step Up Physics, and a 2020 finalist for the PA Teacher of the Year and Fulbright Global Educator. With that being said, I'm going to turn it over to Colleen, and we'll get going. Thank you.
Yeah, thanks so much. I forgot about all those things. So good morning, everyone. It's nice to see some familiar faces, or at least some familiar names out there. We'll go ahead and get started right away, because your time is super important, and as to me as well. So today we're going to be talking about Pennsylvania's new science standards, but actually we'll learn that STEELS actually stands for more than science. There's a lot more that you can do with it than just teach science. And you being in the out of school realm, that puts you in a whole different place. So basically, we're going to just talk a little bit about why we're changing the science standards, and then we'll take an introductory and I'll show you where you can find them. A little bit of implementation and testing, and then we'll actually do a mini lesson and work on it from there. So that's sort of the game plan. We do have an opportunity to send you into some rooms to chat with each other and to get your ideas. And so this is actually our first opportunity to meet the people that you're going to be working with throughout this webinar. And our question is, how did you become involved in the out-of-school teaching field, or out-of-school time field? So whether you're teaching or whether you're administrating, how did you get where you are? And then once you've heard from everybody in your room, can you find patterns in how you got to where you're at? And so what my question when you come back will be, a note in the chat as to what patterns you found in how you got to where you're at. Or if you found none, that's okay too. Is there any questions on the first opportunity to be in a room? All right, well, those of you that are back, my question to you is, did you find any patterns from the people in your group? And you can either put them in the chat, or you can unmute and feel free to share if you saw that, like similar ways that you got into the out of school time field.
It was an alternative to being a teacher, but still wanting to work with children.
Okay, so there were a couple in your group that said, I want to work with kids, but I'm going to do it in this space. Cool. Thanks for sharing. What else we got here?
Chat reads some exposure to programs and new opportunities. Many of us had some exposure either volunteering in OST programs or being in one themselves. So the alumni of the OST space, passion for lifelong learning with ourselves.
Oh, so cool.
Yes.
So I usually ask this question to educators. So you're an interesting new data set for me. Most educators, it's about half of them knew they wanted to be a teacher from whenever, and the other half came in a back door. They either had a great experience in education, but they wanted to be an accountant. Anyway, so I'll have to think about all the ways that you get in there, but we were talking about the importance of your work and how you can help support the educators that are basically under the gun with some PSSAs. But what I really wanted you to talk about was, you see that question, do you see any patterns? That question is a scientific practice. That's what scientists do. They spend a lot of time looking at data. And so what you did right now in this context was that you collected some data from each other, and then you tried to see if there were any patterns in your data. So anything else in the chat?
Lori just mentioned that she saw a gap in needs and sought to fill the gap during the OST program in space.
Nice.
Not just me, our group, our group as a whole, that was like a commonality. It's like there was a need for something. And somebody actually went from working in a scientific field, engineering, I can't remember which her position was, but to do out of school time because she was volunteering or doing programming with a group. And then she ended up transitioning her career to meet that need.
Oh, that's awesome. That is awesome. Yes, great. So this is the sort of thing, but I know sometimes people, when they think about science or technology and engineering, we sort of get a little squeamish. But if we think about using the scientific practices in everyday situations and being curious like scientists are, you can be implementing the STEELS with your out of school time.
Right. And Deanna said it was bioengineering. I apologize, Deanna.
Well, Deanna, great for you. That's just a real calling of the heart. I feel like education found you. So here is one of the reasons why the science standards were changed. The last time the science standards were updated was 2002. So 22 years later, we're updating them. But as you all know, we sort of live in this really wild part of I feel like it's a wild west out there on the internet, where there's just a lot of false claims being made. And we now know some research from this fall is that there's a lot of people on the podcast making false claims about science research and things like that. So my question to you is, if I could move that, in the chat, on a scale from 1 to 10, how confident are you that your students would be able to identify or refute an unsubstantiated or false claim in science or technology or just about anything these days? So just in the chat. We got a 6. I love people that just, yes, you go. And then as you're thinking about that, why did you not say a higher number or a lower number? So if you said a 6, why didn't you say 7? Or if you said a 7, and this is, you don't have to answer this in the chat. This is just sort of like, why did you pick that number? Just a sort of philosophical question. Yeah, Lori's saying about like social media, that's the truth out there, right? Everything that's on the internet and Google. Just my
well, in TikTok, because I had youth say this is where they get all their news, from TikTok. They don't believe anything else but what's on TikTok.
Yes. So if we need to, so what we need to think about is how information is now given, right? So back in the Sputnik was, if you don't know what Sputnik is, it was the first satellite. It was put up by the Russians, and it totally freaked out the American government that there was somebody putting a satellite up, and we were nowhere near that. And so it really started the whole science in schools, and let's do that. But at that time, the teacher was the holder of the school was the body of knowledge. And then all of a sudden, the internet came out in the 1990s, smartphones in the 2010s about, and then it became, instead of knowledge, because everybody can get this knowledge, we need to think about when you're in your school, that science is a process, and that the students really need to, and out of school, I do apologize for always saying school, that students need to think, like, how do we get the scientific data that we get and the knowledge that we get, and what is that process? Because we can look and find the knowledge everywhere. So the knowledge isn't the important, it's the process that's important. So what does that look like in your out of school programs? If we wanted students to be able to reason with and think about the information that they're getting on TikTok, how do you do that? And what does that look like? Again, feel free to unmute if you got an answer, or if you want to put it in the chat. Or if you just want me to,
Some responses in the chat that they try to take students through the research process, building trusting relationships so they come to see you as a reliable source.
Mhm.
Thank you both.
Yeah, thank you. So this is the fundamental shift that we're asking our science teachers across the state and our after school times and our museums and all these folks, is to not just give out the knowledge, but also give them the practices that will lead them to help make better decisions. So these are they're called performance expectations, and we call them STEELS. It stands for Science, Technology and Engineering, and Environmental Literacy and Sustainability. So you folks are in a lovely space because no one's dictating exactly which ones you can. So you can go in and choose the ones that are sort of your heart's desire. Always nice to sort of think about at the grade level that you're at, but you can look at it that way. So on a scale from 1 to 10, how confident are you that you can help implement the STEEL standards in your out of school space? So it's just a quick answer in the chat. Nice, Lori. Thank you. These are can-do folks here.
Yes, absolutely.
At least the ones willing to answer. So it's okay. Well, if you are low on the scale there, that's okay. You came to the right place. We're going to get you at least started with some understanding here. Okay. So here are some of the big ideas around these standards, and some vocabulary words that I sort of want to go through. Sense making. So the word sense making is that students are not being told anything. They're being given the resources and they're the ones that are making sense of it. So they're given a data table and they're going to say, what is this relationship? Or they are given a newspaper article and they're going to look at it and pull out pieces that make sense or things that don't. Phenomena is mostly what we talk about in science. It is something that is super interesting that we can't necessarily explain very easily without digging in and doing some questioning a lot. Some things that count as phenomenon, or like, where do the butterflies come from? How do they get, for kindergarten, right? Where do these butterflies come from? They're not here in the winter, but they're here in the summertime. Where do they come from? Or for middle school, did you know that Mount Everest grows 6 inches every year? How does that happen? And when you get to high school level, you could say, well, what's happening with the coral reefs? Why do they get bleached? So things that are just a real complicated question that kids are interested in, or they love disasters. Like, so how did that, you remember back in Texas when we had that big ice storm and everybody lost power? But it wasn't like so how did that happen and why did that happen? And so and then the other part is the solving problems. So the phenomena is understanding the science, and then solving problems is the engineering piece. When you read these standards, they're written in 3 dimensions, and we'll show you those in a moment. The science and engineering practices, that's what they do. The disciplinary core ideas are the knowledge. And then these cross-cutting concepts are a lens to look at the top 2 that are real world and specific to Pennsylvania, perhaps. Always nice if it is. We always like to go K to 12 so that everybody has it. And it's not just for science, right? It's not just for kids for college. It's also kids that are citizens, because these citizens are the ones that are going to be sort of the people that are buying, the cars. Like, how does a EV car work? And then, of course, we can align it with math, and we just want to do it for everyone. All right, so Pennsylvania has these color schemes. The disciplinary core ideas are blue. If you're blue-green, I do apologize if you're blue-green colorblind. The practices are in green, and the cross-cutting concepts would be in this magenta color. All right, so cross-cutting concepts, this is the list. So just take a moment and look down that. And in the chat, if you could type in other courses that some of these concepts might be found. So for example, an answer might be patterns-math. And you can abbreviate these. We were all in a lovely room together. We could do talk to your neighbor. I love those. Turn and talk.
Some answers here in the chat here, Colleen. So physics, chemistry, or should I say energy plus matter, chemistry, ELA, cause and effect. Good one there, yeah.
Yeah,
Cause
yeah. Even, social studies like systems and system models, like that's our government, right? That's a system. And structure and function, architecture, art, it falls in those. And so when you're thinking about doing experiences in your classroom, think about, not in your classroom, but in your out of school space, think about how you can incorporate these, maybe not even looking at the standards, but how can you pull these out for students? Like that very first things, patterns, we were looking for that in how we all got into OST. And so maybe you can find those sort of things with your students. The problem, however, with patterns is that sometimes humans use patterns to stereotype. And so we do have to be cautious and also make students conscientious of that. It's just because you see a pattern doesn't necessarily mean that one causes the other. So there's also the finding the pattern and then also refining it so that it's not that you don't make judgments on people and things in that. So it's being an adult and becoming an adult is a lot of work, and this hopefully using these scientific ideas and these, so this is the lens to look at your data. Science and engineering practices, then, these are what scientists do. And this is also an important thing that you can do without even looking at the standards. If you take a look at those cross-cutting concepts and you support these science and engineering practices in your space, it doesn't matter nearly as much as to what curriculum you decide to do it with. If you look at these, you might say, oh, the scientific method. How many of you, thumbs up if you've heard of the scientific method? There we go. Yes. So the scientific method is a very linear process. And we're not saying that it's not a good process, but it's really important that with our students that we teach them all of these. When I was in the classroom, admittedly, I was not very good at these last three. I was a physics teacher back in the day, so the mathematics and stuff like that. But I would say that a lot of times when we're doing experiments, we might be good at these top ones, make the experiment, make a model. So also let me clarify, model it. A model is not just a volcano. A graph is a model of like a bowling ball rolling down the hallway, right? We can make a graph of that at the location where it's at and how far and how long it took to get there. So that is a model. A Venn diagram is a model. So if you've seen the water cycle on a poster, that's a model. So a model is a simplified version of a complex idea. So having our students sort of tell us what they think about their models. All right, so, when we talk about art, and the word argument here is not like this kind of argument, it's like, I see what you're saying, but I think that, have you thought about this? Or where did you get your evidence for that? Or how does that evidence point to this conclusion? And so that's when we're talking about argument is those sort of scientific talkings. And then here's your core ideas. The next generation science standards include all of these. Pennsylvania added the environmental literacy. So really exciting because I personally am a tree hugger, if you haven't figured that out. So with my master gardening, and I do have some bees at home too. I'm a beekeeper. Okay, so here's your chance. If you're watching this with somebody next door to you, maybe you can turn and talk to them. But here is a middle school performance expectations that you would find in Pennsylvania. Construct an explanation based on evidence from on how geoscience processes have changed Earth's surface at varying times and spatial scales. And so in that sentence, there are, it has the science and engineering practices like the first slide. It has the disciplinary core ideas and the cross-cutting concepts. And I am going to share, maybe I will, share a website that sort of gives you all of these in one space. I'll put this in the chat, so it'll help you maybe answer that question. So again, this website has all the 3 dimensions. And then that. So you can look at that, and then we'll go back to this. Oops, sorry, there we go. So can you pull out from that sentence the 3 different? So I'll give you a moment to look at that and see if you can pull out the 3 dimensions in that one sentence, that one performance expectation. All right, on the next slide, boom. There we go. So construct an explanation based on evidence, that's a practice. Geoscience processes, that's a disciplinary core idea. And varying time and spatial scales is a cross-cutting concept. So when you look at both the NGSS standards, which are the national standards, and Pennsylvania's own version, the STEELS standards, this is how they are written. They will have those 3 things. So going back to that, I think I have it here. And this is what it looks like, the document on the STEELS Hub. So right here is, if you were writing the PSSAs, this is what you would construct your question on, this particular statement. So you would make students construct an explanation based on evidence on some sort of geoscience process. So the point is that if you can help your students construct explanations from evidence, and you can help them think in times and scales, then when they're presented with data, which will be something that'll be on this, they have the tools to be successful. So again, here's the performance expectation. Here are a clarifying statement, which may or may not tell you. And then if there's some sort of assessment boundary, like students don't need to know, if this were a kindergarten one, like the assessment, students don't need to know plate tectonics or something like that. These boxes then are the 3 dimensions that we were just figuring out. Sorry. Then they always have a Pennsylvania context, PA career context on it. And then the next page, agriculture. So all the different other standards that particular standard is related to. So it helps you, in my ideal world, school would be social studies and science. And then in that context, they would learn, and arts and other things, but in that context, they would then learn math and ELA. I sort of think we keep these silos, and that sort of prevents us from really thinking across all the disciplines. Any questions on what you're looking at here? And if you have a question, you can unmute and ask, or put it in the chat. It's okay, it's lunchtime, we're all hungry. Too much for thinking. Okay, so over here on the maroon side here, these are the things that we're going to be looking at next, just to sort of think about them. Again, learning in 3-dimensional science classrooms or in your out of school spaces. Here's a Venn diagram. So this is a model of how this might work. So that's 3 dimensions. Here is how a unit might pull apart. And I was asking ahead of time, I think best practices is that you don't just do one experience and then you go on to the next something. So this is created, this particular unit model is put together by OpenSciEd. You can Google that. They have all sorts of curriculum that's available for the middle school level that you could think about using. But you start with an anchoring phenomenon, something like I said, where do butterflies come from? How do they get there? And then you have the students give you ideas. So you're not telling them, you're getting their ideas and their initial models about how a butterfly gets there. I think this would be just such a fun thing to find out what kids are thinking. I would love to know where do butterflies come from? Back in the day, humans used to think they came out of the mud and then we did some science and we figured some other things out. So we're sort of helping to engage those students. So what do they know initially? And then what do we not know? So maybe they'll say, well, they live in the summer, but they don't live in the winter. So a question board will be like, well, what happens to this? What happens to the butterflies in the wintertime? And some other driving questions are like, well, what do they eat? And so there'll might be a whole lot of questions that the students will ask, and you keep that in your space. And then you sort of provide, based on these questions, which there's been a lot, you know what those questions are going to be, really, I think, as you get to know your students. Then you can lead them through, you can provide them some reading, you can provide a little direct instruction if you want to, and some investigation. So maybe this is when you go ahead and bring in the butterfly, right? And then like, oh, well, look, there's an egg, and oh, then it hatches and it becomes this. Well, this isn't what we said initially. And so the students, again, are going back to their initial model and trying to piece together what they're learning. And then there might come a point where, well, you said this, and this is what we saw, but does this answer all of our questions? And then again, so you then might do another investigation or do some more digging, and then you're going to keep on putting the pieces together till finally at the end, you've answered all of your questions on your driving question board. So this type of work and these kind of way to put this all together is really time consuming. So it does take time. It's not something that you're going to do in a week in your out of school programs. And it's not something that you as yourself can necessarily create these great ideas, but it's a starting point for looking for ideas with your out of school. And again, learn the progressions are that it's all K to 12. So as you look, you're going to see that the elementary school goes from concrete. So it's things that we can sense with our eyes and our hands and our smells. So the senses, and as they get into upper elementary, you can start using things like rulers and things that we can measure with, but still that's available in our own world. And then if they get up into middle school, then we can start looking at smaller things like in microscopes and bigger things in telescopes. And by the time you get to high school, I don't know how many of you are working with out of school, but now high school and out of school, but now you can start to talk about things that we can't even like necessarily see, like electrons and galaxies and black holes. So that's sort of the progression that we deal with as we're going through. And again, the more we can connect it with our other subjects, the better and the more rich the experience is. And then all students, all standards, all students. And I think when you look at your classrooms and your districts and where your kids are coming from, not every student gets all these standards. And that's a challenge for districts, but that's something that you can help with in your out of school space. Okay, so here's what we're hoping: student-centered, inquiry-based, phenomena and solution focused, aligned K to 12, and for every student. So in the chat, tell me which one for you personally is going to be the easiest with either yourself or in your setting, and which one is going to be the hardest for you to implement. So I'm seeing in the chat, a lot of people, the student-centered, inquiry-based, that's awesome. You guys are used to like getting your kids up and running around, I think, and getting them like out of their seats. A lot of people are confused by the phenomena and the solutions, and how does that get incorporated and such. Okay. So if you want to go to the standards, we will provide this for you. But if you just, yes, aligning, it looks like aligning is going to be pretty hard, especially. Well, that's general consensus. If you just Google STEELS Hub on SAS, it will bring you to this. And you can, all of these are ways that you can interact with the standards. The biggest gripe I have about them is a lot of them are PDFs, so you end up downloading lots of copies. So once you've got them downloaded, you won't need to. A lot of people agree on that alignment. Yeah. So that's an interesting space to work on then. So you know where you need to work. Does anyone have any questions on the STEELS Hub on SAS? Have you been there? Thumbs up if you are familiar with it.
Like a handful. That's about it. Mm-hmm.
Okay, well then maybe just spend a little time, take you there. So yeah, I want to be cognizant of things that are useful for you. So if you Google PA STEELS Hub, it will take you right there to the SAS site. This is run by the Pennsylvania Department of Education, and the SAS site itself is an immense network of all sorts of amazing things and useful information. So if you want to look at the STEELS standards, there's the whole kit and caboodle, that. If you're looking at a specific grade band, I recommend going to the foundation boxes. This is being recorded so people can go back and see things, right?
Yes.
Okay. So if you're looking for, again, so I'll show you that again. If you're on the STEELS Hub, the third one down is all of the standards. So those of you that are administrators, you might want to have that, and download the whole thing. But those of you that are specific grade bands, you can go to the foundation boxes, and then you can open this up and you can see like there's kindergarten, and each one of these is one standard. The trick of the other thing to know, but notice that these are just the science standards. The K-2 environmental literacy and sustainability are just banded. So when you look at this, it's really long, but that's to be distributed out between grades kindergarten through 2. So I will let you, I'll put this in the chat if you haven't found it yet. And I'll let you take a few minutes and just sort of go through it and see if you have any questions. The other thing is, if you find something that you think is really cool or useful, share it with everyone in the chat. So in the chat, either something that you found that's useful, or if you have a question. Doesn't view well from mobile. I'm not surprised. It's a big clunky site. And lots of PDFs. My biggest gripe is that these PDFs, every time I don't even want to touch that because it'll download onto my computer, and I've already got probably 20 copies.
I have a question.
Yeah.
Okay, so one of our biggest challenges is that we just simply don't get the amount of time with students that classroom teachers get. So do you have any recommendations for like prioritizing specific things and incorporating, like, it's just very difficult.
Oh, yeah. I think, well, so I guess it depends on your site. So the first thing, if you are somewhere where you could talk to your teachers, you can ask them like what are the holes for them, and what things do they need supported with? Perhaps, but again, you won't get all your students. Obviously, it's just some of them. Then the other thing is just to think in 15, 20-minute bands, I guess, of time, and how can you break these longer timeframes into smaller pieces? It's like a chapter book, right? We talk about in the science, it's a storyline. And so how can you create a story that's interesting for the students, and like one day from the next, they'll want to, learn something more about it. And less is more. So if you've only got 20 minutes, and make that 20 minutes really just one of the things that you're doing. I don't know. Did that help you?
Yeah, it's definitely a great suggestion to talk to the classroom teachers more about any areas that like to support what they're doing in their classroom. Yeah, I think that's a great idea. But yeah, I mean, like, it's just that we get 20 hours total, for some of our curricula. So
Right.
it's tricky to incorporate it all. And we want to give them as much hands-on time as possible, because that's where, that's where things click. That's where they get excited. And so, yeah, it's hard to do it all.
Exactly. So if you just Google NGSS, and it takes you to the Next Generation Science Standards page, and they do have some quality NGSS units there, and you can sort of do them by grade bands. So you're in the K-2, and down at the bottom you hit apply. These are ones, but they are a unit. And so you'll have to look at it. I just downloaded this one today. So let me see if I can find it. Maybe I'll just do it this way. So this is like push and pulls for kindergarten levels. And if you look at these, it will show you. So you're going to be looking for that initial phenomenon, and then how they kind of piece together the story. And so there's small lessons, and because the same problem you have is the same problem that classroom teachers have, and that they just don't have the time. But a lot of these will talk about how long it takes. So this particular one, the phenomenon is tugboats. How does a big tugboat move a giant, steamer? Like, how does that work? And so the first one is like, what do tugboats do in harbors? And then the second lesson is constructing an anchor. But maybe this lesson is a 45-minute lesson, and you're going to have to break it into 20-minute segments. So I guess my advice is to find some good resources that are out there that give you the start, and then you're going to modify it for your own space. That was a great question.
Yes. Colleen, just a heads up, we got about 9 minutes left. I know we were going to do another breakout. We probably have to bypass that, but just giving you a timestamp there.
Okay, thank you. Let's just do a quick sort of lesson. Hopefully this won't take real long. So this would be an elementary one, and I'm gonna sort of rush through this, which is not the thing. But the story. So this is a storyline. The story goes, there's some Inuit children that were walking along a stream. So this is the introductory phenomenon. And when they're there, they look down and they find this bone that they weren't familiar with. So they take the bone back to their elders. The elders look at it and said, well, this isn't a bone, this is a rock, and it's nothing that we've ever hunted here before. So it's not like from seals or whales. So they ended up, so it was found up in here. They ended up sending it down to Juneau, and the Juneau scientists looked at it and they carbon dated it and said, oh, well, this is 30 million years old, and it's from one of those duck-billed dinosaurs who only lived in the tropics, lived in hot places. And so there's all sorts of questions that kids are going to ask from that. And so what you do is you ask the kids, like, what do you know about Alaska? And well, how did something that was in a hot space in the tropics end up getting into Alaska? And so you get this whole big question, if you think about that scheme I was telling you about. So the initial phenomenon is this bone, this rock bone that was found, and the questions. And when then you might give them more background knowledge, and then this would be the second step, where they're going to be looking at more of the story. But we spend this with some observations. So I'm going to show you something, and I want you to think about the difference between observations, inferences, and explanations. And you'll have to talk about that with kids, but observations, going back to help you remember, is that observations are things that you sense. They're from, especially with the little ones, it's things they see, things they smell, things they touch, things they hear. Those are observations. Oftentimes we take observations and make inferences from them and then explain things based on our inferences. These are big words that you might want to talk about with your kids and what that means, but it's really important that we look at it. We help our students with this idea. So the story, continuing our story, the scientists have now come back and they are walking, like this would be they're walking along the stream. Then this is about the spot where they found the students found that bone. And so hopefully you get that. So we're looking at it this way. And on this side, we're looking down. And when they look down where that bone was found on that same level, they see these footprints in the rock. So these footprints are stone footprints in the stone, footprints in the stone from the same level as that bone was found. So take a moment. How are we doing here? What you would do is you would ask the kids to make some observations, and pretty quickly they'll say, oh, I see this one is big and this one is small. And you're like, well, you could see that these are bigger footprints, but that doesn't necessarily mean that this is a bigger dinosaur, right? Or if they're even dinosaurs, right? So, or they might also say, well, I notice here that the footprints are close together and they're further apart here. So that means he's running. And that's the inference. So there's a lot of time where you sort of have to keep bringing the kids back to what do you observe versus what are you inferring? And then they might give some explanations. So I'm saying that this one's just walking along and this one saw it and it's running up to it and it's going to eat it. Then they dig out some of the rocks and now this is what happens. And then they're like, oh, well, now maybe there's a fight going on. Or they could say, oh, maybe this is a mother and their baby. But again, you have to say to them, is this what you are seeing? Or is this what you are inferring from what you're seeing? And so you sort of help them scope that out, that just because you see something doesn't necessarily mean it's that. Maybe this could be a hippo and a sort of scenario like a hippo with a little bird eating the fleas off of it. Apparently, I didn't know this. Someone told me that turkeys follow deer for the same reason, that the turkeys will eat the ticks and stuff off the deer. That's kind of gross. Anyway, last thing, they dug away some more of this gravel. So this is the gravels, and they're digging away more of the gravel, and they reveal this. And everybody goes, oh, they lost. But of course, you don't know that's what happened. That's what you are inferring. All you can actually observe is that there's one set of footprints. What happened is a couple of things. The bird's now on top. This little guy's now on top of him, or he flew away, or he got eaten, right? There's all sorts of things, but the truth is that we don't know what happened because it was 30 million years ago, and this is one data point. And so we really just need to think about science is a practice, and that instead of, and it's really important that our students can be able to think this way and take a step back from what they are seeing on TikTok and all those places and observing and where that is and what the explanation is coming from. Just because you observe something doesn't mean it's an inference. I'm going to skip through the PSSA stuff and kind of get to this. This will all be available to you at the end. So on a scale of 1 to 10, how confident do you feel now that you would be able to, what have you learned and help with implementation? And more importantly, what is your next step?
So we'll ask anyone to unmute their mic and speak, or go ahead and use the chat. Taking a more in-depth look at those standards, Colleen, is being expressed in the chat. Definitely progress, moving from an 8 to a 10 as far as some confidence builders. So that's great.
All right. Well, I am very happy to always appreciate everything. Nice. Yeah, I appreciate that you can reach out to me anytime, or if you're in a different IU, like there are people like me throughout the state that have all this sort of knowledge and can be a real use, you can reach out to and get ideas with where to go for curriculum and how to implement some things in out of school spaces. So there's help wherever you need it.
Looking to get your contact information in the chat here real quick, Colleen, and
Okay.
be a little bit easier to reach out to you.
All right. Thanks
goodbye.
all of you. You've been a great audience. I appreciate everybody that reflected and gave me some feedback. And I'll stick around as long as anybody wants for questions.
Thank you.
Thanks.
Yes, thank you everyone for tuning in, logging in. We look forward to our next session in 2 weeks. Again, if you got any questions, reach out to Colleen, or you can reach out to the Poseidon Network, and we can provide resources or contacts as well. Hope you all have a great day. We'll follow up with the recording and the slide deck to this presentation. And again, look forward to you joining us at our next meeting. Have a great day, everyone.